Okay, this is lesson 49. I'm starting lesson 49, bar graphs. So we're starting part of the year as we look at statistics, which is looking at numbers and organizing and making sense of them. Okay, so you need to know how to look at numbers and make sense of them, and there's different ways we show numbers. There's bar graphs, line graphs, histograms, pie charts, and even box and whisker charts. And then in statistics, you look at like distribution curves, if you're going to take that in high school. And we have data all around us. Data is just a bunch of numbers, and numbers are math, so we have to know how to look at numbers and organize them, okay? So the steps we're going to learn specifically today is how to make a bar graph, okay, which is right here, bar graph. And it kind of looks like this. I don't know if you've ever seen something that looks like this. You might have seen something. Okay. Yeah, raise your hand if you've seen something that looks like that. Okay. So newspapers, you see them, or maybe like on an article online or blog, you might see something like that. So these are the steps for today. We're going to learn how to graph them, but you have to figure out, there's only one item we're comparing. We're going to identify there's populations, and we're going to write them down in the x-axis and so forth. I'm going to teach you how to do that. But I'd like you to write this down right now. This is what bar graphs do, okay? I want you to write this down specifically. They compare one item between many populations, okay? Or one thing, okay? So write this down. I need you to write this down. This is the purpose of a bar graph. It compares one thing to many populations. And populations could be, a population is a group of people, okay? Of 2 or more people. So right now you're all a population. So a good way to think about it is, we have small populations. My first period class is its own population. Second period class is its own population. This class is its own population. Okay? Or our high school is a huge population, right, of students. It's not the whole population of the U.S., but it's the population of our high school, right? And we could compare our population to another high school, like Bonita High School, or we could compare it to any other high school where they have their own population. Or we could look at even bigger scale, the population of the United States, right? We have a population of people. They might all have something in common. They might have one item in common. So anyways, we're going to compare one item to many populations, okay? That's the goal for today. So here we go. Look up here. I'm going to make one graph at a time, and I'm going to teach you how to do that, okay? So, on your paper it says Mr. Rink's students, okay? And it gives me a bunch of data. Period 1 I have 27, period 2, 32. 3 I have no students, 4 I have 19, 5th I have 15 students, 6 I have 32, 7 I have 28 students. Okay, that's what I have this year, as of now. People come and go, but that's the data that's given to me, or to us in their problem. So the first thing I want to do is figure out what's being compared. What's the item? Well, the item that's being compared is the number of students I have, right? That's the actual item that's being compared. The next thing we're going to do is identify the populations and write them in the x-axis. So we have populations here. So the populations are actually the identification of each population, or the names of each population is period 1, period 2, period 3, period 4, period 5, and period 6. So I'm going to go on my x-axis, and I'm going to write these down. We have period 1, period 2, period 3, period 4, period 5, period 6, and period 7. Okay, I'm going to put that at the end here. Make my line a little bit longer. Okay? So those are the names of my populations, okay? Just like the names of the populations in like the world, the countries, we have the population. The name of the USA is United States. The identity of the country to the south of us is Mexico. The identity of the country to the north of us is Canada. We all each have populations, okay? Okay, the next thing we want to do is figure out what the lowest and highest amounts are. So I'm going to look at my populations I have here, or the actual thing we're talking about, which is the number of students in each population. So we have 27, 32, 0, 19, 15, 32, and 28. Okay, so I have to ask myself, what's the lowest number? What's the lowest number up here, everyone? 0. What's the highest number? 32. So I could go from maybe 0 to 35. Can I have negative students? Is it possible for me to have negative students? Okay, so 0 will be my lowest. and 35 is my highest. So I'm thinking I'm going to go by 5. So I'm going to go 0, 5, 10, 15, 20, 25, 30, and 35, right? That's probably as high as I need to go is 35, okay? And now I just start graphing, which is the last thing, step 4. So period 1, let's focus on period 1. So I'm just going to make a box for them. And I'm literally going to draw a box. So period 1, 27. So I'm going to start from the bottom and go up to 27, which is a little bit higher than 25, right? Can y'all see that? Is that thick enough? Or let me make it a little bit bigger. Try that again. So a little bit higher than 25 is 27, so it's about there. Okay? And then period 2 we said is 32, so I'm going to continue from that point. Go a little bit higher than 32. And the next one is 0. So do I draw anything for 0 for period 3? No, we leave that one alone. Period 4 is 19. So I go a little bit below 20. Period 5 is 15, so I'm right on the dot with 15 here. Oh, that's kind of poorly done. Let's try that again. It's still not there. Why can't I get it? There we go. And then the next one is 32 for period 6. Is that right? Mm-hmm. Still can't get it. How high do I go? Let's try this again. It takes a little bit of careful drawing, so actually I'll just use another method here. In the last period I have 28, which I'm just going to draw a line across. And draw a line down. That's it, okay? Now I can also color these if I wanted to. You know, if you have color pencils, it's cool. I can make one yellow, maybe. Period 1 is yellow. Period 2, I could do like gray. Okay, period 3, there's no one. Period 4. We could do pink. Yes. Period 5, let's do green. Right? And I would color it carefully. I'm using my iPad, so it's a little bit harder to draw in here. But purple, and maybe the last one could be red. Okay? And you could shade them neatly, right? And that gives us an idea, right? So now all of these items are all colored, and now we can compare them, right? Where are most of my students now? We could even ask ourselves from looking at this. We could see a picture of it, okay? Where are most of my students? Do I have more of my students at the beginning of the day or at the end of the day? I think more at the end, right? Because the beginning of the day is, I know that the first part of my day is like periods 1 through 4, right? About here, halfway through here. I feel like there's more students here than there, right? So I would say there are more students at the end of the day, right? What's the most amount of students that I have? 32. Are there any unusual periods?
Period 3.
Period 3. What's wrong with period 3? No students, right? Teachers usually have one period a day. They have conference period where they work on lesson planning and other administrative stuff. Okay, so this is what my day looks like, right? I can take a picture of it. So again, a bar graph compares one thing. What's the one thing I'm comparing here in this example? The number of students, right? But I don't have any in period 3, so that kind of ruins everything.
No, you said 1 through 4 is the beginning, and then 5 through 7 would be the end. So there's more in the beginning than the end.
60, 80. Okay. I would think, whatever, it's fine. I think it's still, I have more at the end, but that's fine. All right, so you can make your suggestions on what the data says. That's what statistics is also. A statistician, a professional, can make numbers work for you or against you. people hire statisticians all the time for their businesses, okay? To calculate as consultants, okay? And a statistician, by the way, is if you're into numbers and you're into doing, calculations, they make a lot of money. So, all right? So, I'm going to pause. Okay, continuing. This is the second example, okay? Here's another way. So we get numbers all the time. You might be like a coach, or you might be into the high school football scene, okay? So these aren't accurate numbers by any means, but let's say these were numbers we wanted to compare. So we have San Dimas has 8 wins, Bonita 7, Glendora 6, Claremont 8, Pomona 9. I'm not sure what they are, okay? So they're all kind of close, but first thing again we want to do, we have to figure out what's the item being compared. The item being compared is the number of wins, okay? Second thing, identify all the populations and write them on the x-axis. So why don't you do this along with me since we already solved the first one. I'm going to draw an x-axis, and we're going to just write these down, okay? So we got San Dimas, I'm going to put SD. Bonita, I'm going to put BON. Glendora, J-L-E-N, or G-L-E-N. Okay, Claremont. And Pomona. Okay, so that's the second step. Third step, identify the lowest and highest amounts of the item and create a scale on the y-axis. Okay, so what are the lowest and highest amounts? What's the lowest amount up there? 6. Highest amount? 9. Okay, so we could go by 3s. I could go up a little higher, just go by 2s, go up to 10. I think I'm going to go up to 10. Does it matter what your scale is? No. It's whatever you want. Remember, as a statistician, you can make your numbers look the way you want, okay? Because some people make them look like obviously not a big deal. I'm going to make them look like they go up to 10. So we'll put 0 at the bottom, 2, 4, 6, 8, and 10. And that's all I really need for the sake of my graph here. Okay, now I start writing it out. So 8's the tallest, so we got, or no, it's not the tallest. Okay, so San Dimas is 8. Then we know Bonita's 7. So it's in the middle of 6 and 8. And I'm being as neat as possible because this is like the purpose of this is so we could show other people what these numbers represent. So it's like you're presenting it. Okay, next one, Glendora is 6. And Claremont's 8. And last but not least, Pomona 9. Okay. And that's it. Now we could see a visual representation of the teams, all right? Just by looking at this graph alone, are there any teams that had the same amount of wins for the season?
Yeah. San Dimas and Claremont.
San Dimas and Claremont, right? Who had the lowest? Glendora, right? The lowest. Who had the highest? Pomona, okay? So we're comparing one item to a bunch of populations, which the one specific item is the number of wins. We could have even another graph that shows the number of losses, okay? If everyone played the same amount of teams, you'll see like how they're very similar, but they're inverses, okay? Because the more wins you have, the less losses you have, okay? All right, that's number 2. Did you write this down? Okay, let's have you do number 3, okay? You think you could do one on your own? Yeah. Ready? Here we go. Okay, so I'll help you start this up. Identify the item being compared. What's being compared here?
Hours.
Hours of sleep, okay? So, and What's the name of our population, or what are the names of our populations? What's that? The days of the week, right? Or the nights of the week. Would you all agree?
Yes.
Because each night has its own population of hours, right? So, for my particular week, this could look like a normal week for me. So, you'd want to write Monday, Tuesday, Wednesday, Thursday, Friday. And I'm going to use abbreviations because, you can. It doesn't always have to be all written out. When you're using technology, though, you can write it out completely because you could adjust things or format them more neatly. Okay? All right. And then what's the smallest and highest?
The height is 10.
Okay. Okay, so what should your scale be? By 2s, okay. That's fine. All right. I want to see what you do, and then I'll show you what I would do on this one. Like I said, there's a lot of representations, and watch this. This is sometimes what people do too. Look up here. Okay. They'll add this. They'll be like, "Oh, okay." People usually say, "Oh, I got no sleep last night." So, right? But what's the lowest amount of sleep that I had?
6 hours.
What's the biggest?
10.
10. Okay. All right. So then I might make mine look like this. But I'm going to go a little more quickly here. So I'm going to go 8, 7.5, 7, 6. What's that? 10. Then? Oh, I didn't do 6 correctly. Aren't you guys watching what I'm doing?
Yeah,
I was just making sure. I'm just seeing if you were paying attention. You weren't.
I didn't realize.
7. Thursday. 6. 10. Saturday. 9. So this is messy. And Sunday. 9. Okay. Okay, now look what the way I made my graph. Look at how much sleep I get on the weekends. It's really high. It's all like really big, right? And then I get like no sleep. When do I get no sleep? Thursday. But how is that really like no sleep on Thursday night? Is that true? How much difference in sleep is it from Thursday to Friday? It looks like a lot, but how much is it really?
Like 4 hours.
Like 3? No, like 4, right? Right? From here to here is 4. But I got a question. Look at my graph. From there to there it's 4, but look at right here visually. From here to here, how far is it? How far is it from here down to here? 6, right? Good. It's not proportional, right? A lot of people put graphs like this and they'll make it seem like, oh, you only get 6 hours. That's like nothing. Well, actually, it's not true. It's something. They'll do that, and they'll sometimes add this thing in the corner. Look at the bottom left right here, everyone. Look down here. They'll add this little thing called a break down here, and it'll look like this, very small. Okay, but it's kind of like makes it seem like you won't see this. Sometimes they don't. Sometimes it is. It's called a break. Okay, and then it'll make it look like the graph is shrunk. Okay, whereas some people draw their graphs really tall, squished. It depends. What do you want to see, right? Okay. But if you were looking at this the first time, would it look like there's any nights that I get very little sleep? What night does it look like I get very little sleep? Thursday, right? So sometimes you want to emphasize something in your graph. You're like, look at this. Maybe you're trying to prove something. And so you kind of like make the picture look a little bit more squished. Okay? I'm going to end the lesson there because these do take a little while, and you're all getting it, so I don't want to waste your time on practice. So that concludes this lesson.